Every workload requires compute to run and scale. The node pool is a configuration object that provides the bridge between Protean AI and the Kubernetes infrastructure that powers these workloads. Assign a unique name and define the runtime class. The runtime class is critical for GPU-enabled nodes to ensure the container runtime correctly exposes hardware drivers. Leave it blank if the cluster's default runtime exposes the GPU devices and drivers to the container. Select your compute type. Use CPU for lightweight workloads like MCP servers and embedding tasks. For generative tasks and LLMs, selecting GPU is more efficient. In the GPU section, specify the resource name, which should exactly match allocatable resource available on the node in the cluster. Protean supports NVIDIA's standard and MIG configurations. Ensure the GPU request is a whole number. For standard configurations, enter the exact VRAM capacity available to the GPU. For MIG configurations, Protean intelligently extracts the memory data from the profile name, automatically populating the VRAM field for you. Specify requests to define the minimum CPU guaranteed to the workload at all times. The limit defines the maximum CPU the workload is allowed to consume. If the workload attempts to exceed the defined CPU limit, its processing speed will be throttled, but the workload will not be terminated. Similarly, define memory constraints. If the workload exceeds the specified limit, it will lead to workload termination to protect overall system stability. Use the node selector as a hard constraint to pin workloads to specific hardware, such as high-performance GPUs, or even department-level isolation for internal cost control, using exact key-value string matching. To allow workloads to run on nodes with specific taints, configure matching tolerations. Ensure that the tolerations key, operator, and, if applicable, value and effect exactly align with the corresponding taint defined on the node. Use this to guarantee that specialized hardware is reserved exclusively for high-performance fine-tuning and inference workloads. Hit Save to register your node. Next, manage authorization by granting editor or viewer access to specific users or enterprise-wide groups. Viewers can deploy workloads on the nodes, whereas editors can deploy and modify node metadata, deregister the node, and manage security. Editor access is limited strictly to the specific node they are assigned to. It does not grant system-wide permissions or access to other nodes. To remove a node, select Delete. This action is only permitted if the node is not linked to a workload. Deleting the node removes it as a deployment target without impacting the underlying infrastructure. Navigate the registry efficiently using the search tool to filter by node name, runtime class, or memory capacity. Once registered, the node is a live asset. It will automatically appear as a target for model deployments, fine-tuning, or agents for all authorized users.